study was designed to examine the role of television viewing in the lives of people aged over 65 living in Bangkok. Therefore, the population is the people older than 65 years who live in Bangkok. A random sample of 25 senior citizens was selected, so sample size n is 25. The purpose of the study was to determine if the mean number of hours an elderly person spends watching television could be predicted. So the predicted variable is mean number of hours, y. Here also, from the other three variables, so we write the number of predictors is 3. Usually you denote by x1, x2, x3. So x1 is age of the interviewee, x2 number of years of education, years is racial level measurement, x3 marital status. x3 is 1 if the interviewee is living with his or her spouse, if there is a partner, or 0, 1 variable. If not, if living alone. Okay. Therefore, 1 variable is also permitted, and this is called a dummy variable. 3 computer outputs are given below, which is the correct one. Here, check here, observation n is 25, correct. N is here 2. Here the number must be k. So k is 3 and here you see only 2, therefore not correct. Therefore this output is not for this study. And here also x1, x2 only 2, so k is 2, the first, yeah. Not this a1. Check a2. Number of observations 20, so fourth n must be 25. Here k is 3, correct, yeah, but here fourth. Age, education, marital status, this is alright, but n is fourth, therefore not this. The third one, a3, dependent variable hours, short name, that is time, correct. Here k is 3, correct. x1, x2, x3, age, education, marital status, all correct. Therefore, this output is, we have to use this. Predict the mean daily viewing hours of a senior citizen. So, we have to predict this one, y. So, y hat is a, where is a? Here x1, b1. Here a is 1.49526 plus b1. b1 is 0.03876. This one x1 h. b2 negative, yeah, negative 0.15228 times h2. H2 is education, and minus 1.17573 times x3, h3. So this is p3, this is marital status x3. Okay, for prediction, who is living with her or his spouse, therefore x3 is 1. 67 years old. Age 1 is 67. Here you put 67 here, and 11 years of education. So age 2 is 11 education years in education. So after that, compute by calculator. A plus B times 67 minus P1 times 67 minus P2 times 11 minus P3 times 1. Yeah, so P3 value 1. Then you get this predicted hours. And interpret the coefficient of age. Coefficient of age is x1, so you have to interpret b1. b1 is 0.03876. So according to this equation, you can see if x1 increases by 1 year, or if a person in the population increases, if the age of a person in the population increases by 1 year, he or she will watch more longer time television. How much longer? 0.03876 longer for every year. Okay, for 1 year older. So you describe like this. If fixing x2 and x3, or you can write for the same years of education, the same marital status, if a senior citizen gets 1 year older, he or she will watch 0.03876 hours more. He will watch television longer. How much longer? 0.03876 hours longer. Right. Compose well. And example composition is here. Here. This one predicted. If you compute by calculator, you will get this nearest one. Example demonstrates this. Interpretation of coefficient of age. Another one is interpretation of marital status. Marital status is 0 if lives alone. Marital status is 1 if there is a spouse. Therefore, how to interpret marital status? This one. So you check in this equation. If you put 1 here, then minus, negative 1.17578 will be added to y hat. If single, we have to put 0 in x3, then minus 0, minus 0. If there is a spouse, minus 1.17573 times 1 is minus 1.17573. Therefore, if you compare the two predicted values, then 1 will give less y hat. How much less? 1.17573 less. So describe this. If a person if a senior citizen has a spouse, then he will watch less television. How much less? 1.175 hours less. Like this. Compose well. Another number 4 is 0.05 level of significance. For this part, p-value appropriate, p-value a 0.05 level of significance determine whether there is a significant relationship between the swing daily hours senior citizens spend watching television and 3 explanatory variables. That means y hat, y depends upon x1, x2, x3. Global test of significance. F test, yeah, F test, degrees of freedom, k for numerator, m minus k minus 1 for denominator, and right tail, yeah, you have to remember this. F statistic comes from ANOVA table. So you consider the equation, the best linear equation for predicting y using x1, x2, x3, this form. If we could get all data of the population, we could compute the values of alpha, beta 1, beta 2, beta 3. But now we don't have all data of the whole population, therefore we don't know their values. Therefore we are testing. This equation will show dependence of y on x1, x2, x3 if sum of beta 1, beta 2, beta 3 are non-zero. Okay. If all are zero, the equation does not show any relationship of y over x1 to x3. Therefore HO, the equation is nothing. Okay, the equation is nothing. You write like this, and the value of the statistic just copy from ANOVA table. ANOVA table, compute ANOVA table, F statistic, test statistic, then this is p-value, right tail p-value, 0.001, very small, smaller than alpha is 0.05, right? So then reject HO right formally. So test statistic 11.7, p-value is 0.001, like this, yeah. Here you can read critical value and compare, or p-value smaller than alpha, yeah, reject HO, and so on. You write like this. After that, you have to, the question asks if age is a significant explanatory variable. Age can explain y or not, yeah. X can explain derivation watching hour or not. So age is x1. So x1 will contribute to the estimation of y if beta 1 is not 0, right? Beta 1 is 1. If beta 1 is 0, x1, we don't see any relationship of y on x1 age. Therefore, beta 1 0 or not, HO 0. And you read the statistic p-value where T statistic x1 h, p1 is 0.03876, sp1 is 0.03193, p1 divided by sp1 is T statistic 1/21, and this is the T statistic. Its p-value is 0.2382. P-value is small than alpha, reject. This is not small, yeah, not small, so don't reject. And write like this, not rejected. Therefore you have to take beta 1 0, then beta 1 x1 will be 0. So you don't see any contribution of x1 to y like this, not a significant explanatory variable. And after that, 6. To answer 6, there are 3 variables which are significant for y. Each is no more significant, by 5. 5 shows that each is not significant. So how about education? x2, beta 2 0 or not. Test statistic negative 3.04, p value 0.0062, smaller than alpha 0.05, reject HO. Yeah, like this. Reject HO means approve HA. HA is beta 2 is not 0. If beta 2 is not 0, then so you reject HO, approve, accept HA, beta 1 not 0, we accept, beta 2 not 0, beta 3 not 0. So in the equation, in this equation, we confirm that beta 2 is not 0, beta 3 is not 0, we decide beta 1 is 0. Because beta 1 is 0, beta 1 x1 is 0, no more in the equation. Because beta 2 is not 0, beta 2 x2 exists in this equation. So if you change x2, y will change. Similarly, beta 3 is not 0, therefore beta 3 x3 is in the equation. Therefore x3, if you change x3, y will change. The equation shows that y will change. Therefore x2 has effect upon y, x3 has effect upon y. This is the answer to 6. Yeah? Education has effect upon main daily watching, television watching hours, marital status also. Yeah? x2 has effect upon y, x3 has effect upon y. And that's all.